Good morning and welcome to Tuesday's lesson, the second one in our data unit. Today we are going to look at which kind of graphs or charts are best for which kinds of data. So we're going to start off, I'm going to show you lots of different ways of how data can be represented. So this first one's called a scatter graph, and it's used to show a relationship between two different characteristics. So in this case, how much an animal weighs in relation to how fast it is. So we can see that an elephant is right at the top of the weight category and about halfway along the speed line. A rhino's slightly lighter, but is also faster. Then you've got a turtle right on the left-hand side there, which is surprisingly heavy, the old turtle here, but not very fast. So what I'd like you to have a quick think about is, and maybe talk about with someone at home, where would you put a dog on this graph and why? And where would you put a crocodile? See if you've got the same sorts of ideas. Whilst you do that, you can pause the video and have a chat. This kind of graph is called a pictogram. It's used for discrete data, which, as you remember from yesterday, means you can count it. So this is discrete because hurricanes are classified by categories. They're only given one classification, so we can count them in their categories. So these are all hurricanes which happened in the Atlantic Ocean in 2017. Important with a pictogram is that you have a key, like I have here, which shows what the value of each picture is. Often in a pictogram it might be worth 2, 5 or 10, and then people will use half pictures or quarter pictures to show values in between. Frequency table. So this time we've got hurricanes from 1977 in the same area. This is what data looks like first, generally before we've put it into a chart or a graph, but we can just leave it like this and present it like this. It's nice and clear, it's easy to read. I think it's often better when like this, you haven't got too many rows of data. Tally chart, which I'm sure you've seen before, exactly the same layout as the frequency table. In fact, this is using the same data, and this is often what it looks like as we're recording whilst we're collecting the data. Tallies, of course, make it easier to count. Hopefully you remember from previous years that you do 1, 2, 3, 4 vertical lines, and the fifth line bars across those 4, so we're counting in 5s. Next, we've got a bar chart. Lots of confusion about whether the bars in bar charts should touch or not, and the answer is not. They don't touch because the data is discrete, which means that it can be put into separate categories with a gap between them, just like in our pictogram. This time we're back to using an X and a Y axis, and we've used an evenly spaced scale along the Y axis, which allows us to measure how many hurricanes there were in the Atlantic in 2007. You can see from categories 2, 3 and 4 that there weren't any hurricanes in those categories during that year. A line graph is the kind of graph we use when we want to show how something changes over time. So this one is looking at what happens to hurricane wind speed after it's come onto the land. So they're often faster over the ocean, and when they move on to land, they lose power. So this is showing what happens in the first 48 hours after a hurricane hits land. This is a histogram. Looks like a bar chart, but this time the bars touch, and that's because the data down at the bottom here, I've moved my axis. That's not what I wanted to do. Now it won't move back. There's no gaps between those categories. It goes from under 74, 74 to 95, 95 to 110, and so on. So here are hurricanes for 1987. I have to admit that I did actually, I want to move these back, it's annoying me now, and I can't. Oh, yes, I can. I did slightly change the data here because otherwise I had big gaps in the middle. So I've invented a couple of the categories in the middle, hurricanes in the middle categories. So this is a pie chart which we were looking at last week if you were in school. So pie charts are great for comparing sizes or quantities, often associated with percentages which given in data which is given in percentages, and it shows the relationship between each part and the size of the whole. So this is how strong tropical storms in the South Pacific this time were over a 36-year period, and we can see that nearly half of the tropical storms were actually hurricane intensity, gale intensity being the weakest, and it was also the least common out of all of them. So I'm going to give you a choice of 2 tasks for today's lesson. So the first task is I want you to find some data that interests you, or you can collect your own in your garden or looking out the window or ringing up people in your family. And I want you to present your data in the most suitable chart or graph. And you need to explain why you've chosen those, why it was a good choice. And then I want you to explain one type of chart or graph that isn't suitable for the data you've collected. The second task you could do is there is a task on the Enrich website. You need to use that website address. It's called Where Are You Flying? And it gives you some data in different formats. And when you look at the questions at the bottom, you'll see that you have to discuss about how good the different representations are, what are their strengths and weaknesses. So you can do either of those tasks. You can do both if you're feeling very motivated. So what I'm going to do for the rest of this video is go through an example of my own for task 1, which you can use as a waggle. So I found this data, took it off Wikipedia, and it's the Summer Olympics medal table from the London Olympics in 2012. So this table goes on quite a long way down. There were, I think, 85 different countries that took part. So I've just put a snapshot of the top part of it on there for you. There's lots of questions I can ask of this data. There's lots of different graphs and charts I could make, so I needed to come up with a question. So my question I decided was, who won the most gold medals? So there are 2 suitable charts I could use because I've got discrete data. It's countable. You don't win half a gold medal. So the first one was a bar chart, where I could show exactly how many medals each country got. So as you'll notice, though, it doesn't show it exactly on my chart because the lines go up in 20s. The reason the scale is so big is because of this final column on the right hand side here, which is how many medals were won by 46 of the other countries. So it didn't look quite as good as I wanted, but I wasn't sure how to deal with all those countries who won less than 10 medals. So I thought, well, a pie chart would show the comparison between countries and between each country and the whole, and I could put all of those countries with less than 10 medals into one sector. But kind of the same problem again. The country which won the most, which is the US, you can see from the key, it still looks tiny compared to those 46 other countries. Maybe I should have made my question amongst the top 10 scoring countries to see who won what. So between the two, I think the bar chart was still a clearer way of showing the answer to my question. But the difficulty was there were so many countries who won gold medals but didn't win more than 10. There were only a few who won more than 5. So I came up with a slightly different way of presenting my data, and I decided to put in how many countries won gold at the 2012 Olympics. So you can see there that only one country won between 40 and 50 golds, one country won between 30 and 40, one won between 20 and 30, 3 won between 10 and 20, and then 46, as we know, won between 1 and 10, and then about 30 countries exactly didn't win any gold medals. So maybe this is more effective. I think if I'd drawn this myself, I would have wanted to show exactly that was 1 or 2 or 3 countries at the bottom, and I probably would have been better off doing this myself on graph paper than using Excel. I don't mind which one you do. So which graphs wouldn't have worked? Well, I couldn't have used a line graph because I'm not showing a change over time. And a histogram wouldn't be suitable because my data's discrete, it's countable. There's, a distinct difference between 1 gold medal and 2 gold medals. So a histogram would have been inappropriate. I hope that makes sense. Hope I haven't gone through that too fast. I hope you are all staying safe, staying inside, keeping healthy and keeping learning. Don't forget to listen to the Arsenic for Tea book videos as well. I will upload part 3 later today. See you tomorrow.